Okay, an easier equation to look at this time, but notice that the directions have changed. No longer are we solving over the interval 0 to 2 pi. Now we're just asked to solve the equation. It means we want all the solutions to the equation. So specifically, and what we'll find out, not just the solutions going around the circle once. What if you go around the circle twice, or 3 times, or 4 times, or you just keep going around the circle? We want every solution to this equation, regardless of how many times you go around the circle. Okay. Well, solving this equation is not hard. We're going to subtract 1, divide by 2. So we get cosine x equals negative 1/2. So for now, let's just consider going around the circle one time. Where does cosine have a value of negative 1/2? Cosine has a value of negative 1/2. That would happen 2 places. Let's actually draw this because we're going to need the drawing anyway to understand how to finish the problem. So cosine is equal to negative 1/2 at this angle. Okay, this angle is 2 pi over 3, and also at this angle, which is 4 pi over 3. So there's my solutions. Alright, so that would be the solution if we're only going from 0 to 2 pi. Okay, but we don't want to go just 0 to 2 pi. We want to consider other values that would also have a cosine of negative 1/2. So here's how I do that. I start by, so here's, just draw on here. There's the first angle up to 2 pi over 3. I could continue around the circle and stop right there. Now if I were to do that, what did I just add to 2 pi over 3? I went around the circle an entire time. One rotation of the circle is how many radians? One rotation is equal to 2 pi radians. Okay, so this could be also 2 pi over 3 plus 2 pi. But I don't need to stop there. I could go around the circle again. So it could be 2 pi over 3 plus 4 pi. That's another 2 pi. Now I can keep adding 2 pi over and over and over and over and over again, and I could never stop, right? So this solution can be summarized 2 pi over 3 plus, I'm going to say 2 pi n, where n is the number of revolutions around this circle. Okay? If n is 0, then we just have that. If n is 1, we have that. If n is 2, we have this. If n is 3, we have a third time around, etc. So that's a solution. The other solution then is found the same way. It's 4 pi over 3 plus 2 pi n. Okay, so that addition of the factor or the term 2 pi n accounts for multiple revolutions around the circle. Okay, it's what we want to do when we're asked to solve the equation, not over an interval, but just solve the equation, all solutions. Next example, 3 secant squared x minus 4. We actually just saw the exact same problem. I think maybe it was 2 slides ago that equation resulted, and we finished it. Let's just kind of pick up there. This would be the same as, I'll show just a couple steps. Secant squared x would equal 4/3. Take the square root. Secant x is plus or minus 2 over square root of 3, which is the same as cosine x equals plus minus square root of 3 over 2. Alright, how are we going to deal with this problem when the directions say solve the equation, not solve the equation over the interval? Let me again kind of show this. There are four angles that are solutions to this equation. The four angles are right here at pi over 6, right here at 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, there are four solutions to this equation over the interval 0 to 2 pi. Now what I want you to notice is that these angles, these pairs of angles, are only a half circle apart from each other. Instead of doing this, and instead of writing them all like this, there's a better way to do it. I can consolidate these two answers as they are only half a circle away from each other. If a full circle is 2 pi, we know half a circle is 1 pi. So I'm going to write it as pi over 6 plus, instead of 2 pi n, pi n. So that's starting at pi over 6, add pi, I'm here. Add pi, we're back. Add pi, we're back. Add pi, we're back, etc. So I'm counting by just 1 pi instead of 2 pi. Likewise, I'll do the same thing for these two. Take 5 pi over 6. I'm going to add pi n. I will just say this, it would not be wrong to write 4 answers and have all 4 answers look like that. This is just like writing half as much, I guess. So maybe preferred. Okay, this next one, solve the equation. So not 0 to 2 pi, we want all solutions. This equation, lucky for us, it's already in a factored form, so we can just set the factors equal to 0. This one would be, I'm going to do a couple steps as I do it, would be tan squared x equals 1/3. So that means tan x is equal to plus minus, I want the square root of 1/3, which would be 1 over square root of 3, or tan x is equal to plus minus square root of 3 over 3. This one is tangent squared x equals 3, so tan x equals plus minus square root of 3. I want all the places where tangent has one of these values. Okay, it might help to see the circle. So let's see, the square root of 3 over 3 points first. Tangent's equal to square root of 3 over 3 whenever we have a y value of a half and an x value of square root of 3 over 2. So that is this one, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6. So let's write those answers out. I could take pi over 6 plus n pi and 5 pi over 6 plus n pi. Now we also have to consider, where does tangent equal plus and minus square root of 3? That happens here at pi over 3, 2 pi over 3, this would be 4 pi over 3, 5 pi over 3. Notice these two are half a circle apart, these two are half a circle apart. So I'd also have solutions of pi over 3 plus n pi, that takes care of these two, and 2 pi over 3 plus n pi takes care of these two. So we want all of these answers. It's a lot of spots on the circle that solve this equation.